In this video, I want to explain how to represent negative numbers using excess K. So let's imagine that we have only 4 bits for representing numbers. We have a small binary number. So with 4 bits, we only have 16 different values that we can represent. And if we are representing integers, remember that will go from 0 to 2 raised to the fourth power. Fourth is because we have 4 different digits, minus 1. This is equal to 15. So 16 different quantities from 0 to 15. I'm going to write them here in order. So we'll have 0, 1, 2, 3, 4, and so on. Okay. So if we want to represent negative numbers, one simple way to do it is just that to split that in half. So we will split this, and half of the numbers will be if we have 2 to the fourth power, and we divide this by 2, 2 raised to the third power. So we take the first 8 digits for negative numbers and the rest of the numbers for positive numbers. So these are the first 8 numbers, and these are the other 8 numbers. We have 8 quantities here and 8 quantities here. So we put the 0 here. This is a convention. We can do it in different ways, but we can put a 0 here. So this will be minus 1, minus 2, minus 3, minus 4, minus 5, 8. And this will be 1, 2, 3, 4, 5, and 7. So this is a way of representing the numbers using excess K. So how do we know the number represented by a binary number? So imagine that we have here, for example, we have 1001, this number. What's the equivalent in decimally? We have excess K. So for excess K, we need to know the K. So the K is used for splitting the number. So in this case, K, we have used 2 raised to the third power. This is, you put the separation between negative and positive just before that number. This is 8, so you put the separation here before the in the eighth position, to take eighth position. So the first thing to do is to um, convert this to decimal. So this will be, remember, it's 1, 2, 4, and 8. It will be 9. 8 plus 1, it will be 9. So 9, if we count from here, here is the position. So what do we need to do to know what's the number in decimal system? We need to subtract the k. Because we have taken 8 numbers as negative, so we subtract 8 numbers, and this will be the number 1. Or just it's the same as just counting from here and starting to count positives at the x position. So the 1, this will be the 1. So for example, imagine that we have a smaller number. We have 0, 0, 1, 1. This is 3. So we subtract 8. So this is minus 5. It's the same as counting from here. We count, we search the number here. So this will be 0, 1, 2, 3. And this is the equivalent will be minus 5. So that's the representation of numbers with excess K. So to know what's the real number represented, it will be the number minus k. In this case, we're using a k as 2 raised to the n minus 1. In this case, the 0 will be here in the positive part of the numbers. So how do we do the opposite? The opposite is to calculate, to know the binary representation is just adding the number. So for example, if we want to represent 7, we add the k, this is k, and this is 15. So it will be 4 ones, and that will be the representation. Taking account that you can't have more than 7 because the range will vary. So the range that you can represent will be from minus k to plus k minus 1. This will be the range. In this case, we are taking k as a, so we can represent minus 8 to 7. So in this case, remember that you can write all the numbers here. This will be minus 8, this will be 7, will be the equivalent. So for example, let's see how to represent a negative number. Minus 3, we add a, this will be 5, and it will be 1, 0, 0, 1, will be the representation. So that's it. It's as simple as that. Just splitting the numbers by a quantity, and half of them will be negative and the other half will be positive.